Now we are moving on to perform the indicated operations and simplify. And if you notice on this problem, the indicated operation is multiplication. Actually, on both of these problems, the indicated operation is multiplication. I can see that right here and right here. Remember, when you're multiplying fractions, which is what we're doing here, they're rational expressions, which means fractions, we multiply across the numerators, multiply across the denominators, and then if there is anything that could still be reduced, you do that. Alternately, you can look for anything that can be divided out before you multiply. Do that first and then multiply what's remaining, which is actually the way we're going to do it here. So I'm looking at this first problem and I'm looking for anything that's alike in the numerator and denominator. And remember, it doesn't have to be just in this numerator and denominator or this numerator and denominator. I can cross across fractions, because if I multiplied it all out first, it would all be one fraction. So the first thing I recognize that I can do is take the 7 and divide into the 14. 7 divides into 14 two times, and the 7 now becomes 1, of course. Now I'm going to look at x cubed over x to the 8th. Remember, we use our quotient rule for that. I can either say 3 minus 8 is negative 5, and if the exponent is negative, it's on the bottom of the fraction, or I can say 8 minus 3 is positive 5, and then put it where the larger denominator was, and that's what I'm going to say. Okay, that x to the 3rd divides into that x to the 8th 5 times. So now I have x to the 5th in the bottom, because that's where my bigger exponent was. I have y squared over y to the 8th, and again, the y squared divides out. Y to the 8th now becomes y to the 6th. Whoops. There we go, y to the 6th. So everything in my numerator divided out, if you notice. So I'm left with a 1 in my numerator. And in my denominator, I have 2, and I'm going to put my variables alphabetically. X to the 5th. Looks like I divided out that whole x there, but I didn't. That should still be there. And y to the 6th. And that's my final answer, because I have no more terms in the numerator and denominator that divide out evenly or become 1. Okay, moving over here, I now have variables that, not variables, I have expressions that need to be factored. So when I look at the first one, 2x squared minus 7x plus 3, that factors to x minus 3 times 2x minus 1. Remember, what I was doing here was, because there was no GCF, I took 2 and multiplied by 3. I was looking for what multiplied to 6 and added to negative 7, which was negative 6 and negative 1. That multiplied to positive 6, added to negative 7. I separated the negative 7x into negative 6x minus 1x, and then I finished factoring by grouping. My denominator, I have x squared minus 9, which gives me x minus 3 times x plus 3. Difference of squares is always the sum and difference of the roots, in either order, of course. Okay, now I'm multiplying that by 3x squared plus 8x minus 3. Let me just show you over here, since 3 of these are the same kind of factoring, I'll show you this one. 3 times negative 3 is negative 9. I'm looking for what multiplies to negative 9 and adds to positive 8, which of course is 9 and negative 1, and that's how I'm going to separate 8x. It becomes 3x squared plus 9x minus x minus 3, and then I do grouping. What's alike here is 3x, and that leaves me x plus 3, which is what I want in my second parentheses, and I have negative x minus 3, so I factor out negative 1, running out of space here. That gives me x plus 3. So what I end up with is the x plus 3 that's in parentheses for both of those terms, and the 3x minus 1 that was outside of the parentheses. It's a little sloppy there, but I did want to show you one of those factoring a trinomial with a leading coefficient problems. Okay, now I have 6x squared minus 1, which is going to give me 3x minus 1 times 2x plus 1. And now remember, when I do this problem, if I'm not sure about my factoring, I can FOIL back to check it. I have 3x times 2x is 6x squared. Outer is plus 3x. Inner is minus 2x. 3x minus 2x gives me x. And then negative 1 times positive 1 is negative 1. So I showed you one of those three, but all three of these factored in that same way, the AC method or the T-chart method, or of course you can use trial and error. Whatever method you have for factoring those is perfectly fine. Now that everything is factored, I want to look at the top and the bottom for like factors, and you can see I have a 3x minus 1 that's alike. I have an x plus 3 that's alike. I have an x minus 3 that's alike, and I'm left in the numerator with 2x minus 1, and in the denominator with 2x plus 1. Those are not the same. They're not opposites of each other, so there's nothing I can do with those. 2x minus 1 over 2x plus 1. Now wait a minute. I said there was nothing I could do with those. Can I divide out those two x's? Think about it a second. And I hope you're saying, of course not, Miss Nystrom, those don't divide out because neither one of those is a factor. This is a term in that binomial, this is a term in that binomial, and therefore they can't be divided out because we can only divide out factors. So in fact, that is my final answer.